Chemistry model questions. Frequently asked questions answers. Top 50 very short questions answers, 2 marks. 1. Define chemical equation. A chemical equation is the symbolic representation of a chemical change or chemical reaction. Example: hydrogen reacts with nitrogen to give ammonia. 3H2 plus N2 right pointing arrow to NH3. 2. What is polymerization reaction? Give examples. Polymerization reaction is the reaction in which monomers like ethene and ethine polymerize to give polymers like polythene and benzene respectively. Example: 3 molecules of ethyne acetylene polymerize to give benzene I. E. 3C2H2 right pointing arrow C6H6. 3. What are antacids? Write its medical uses. Antacids are the chemical substances that help to reduce hyperacidity in human stomach and provides relief from heartburn, indigestion, peptic ulcer, etc. Medical uses of antacids. Antacid is used to treat stomach upset, heartburn, and acid indigestion. It is also used to relieve symptoms of extra gas such as belching, bloating, and feelings of pressure discomfort in the stomach gut. Simethicone helps break up gas bubbles in the gut. 4. Define antipyretic and analgesic drug with example. The drugs which are used to lower body temperature to normal in high fever are called antipyretics. Phenacetin, paracetamol, aspirin, etc. The drugs which are used to relieve pain without loss of consciousness are called analgesics. They are also called painkillers. These are effective in headaches, muscle pain, and joint pains, etc. For example, Brufen, Novalgin, aspirin, etc. 5. Why is CO toxic? Carbon monoxide has higher affinity than oxygen towards hemoglobin. So, carbon monoxide combines with hemoglobin to form carboxyhemoglobin. Carboxyhemoglobin is stable complex. This reduces the oxygen content in blood. As a result, suffocation takes place and may cause silent death. Hence, Colorado is toxic. 6. What happens when carbon monoxide is heated with nickel metal at about 1500 C? When carbon monoxide is heated with nickel at about 1500 C, nickel tetracarbonyl is formed. Ni plus 4 CO right pointing arrow Ni, CO4. 7. Write the Lewis structure of H2SO4, H2O and NH3. 8. Define surface tension and viscosity. The surface tension of liquid is defined as the tangential force acting along the surface of the liquid at right angle to a line of unit length drawn on the surface of liquid. The internal resistance to the flow of liquid is called viscosity. Alternatively, the viscosity of liquid may be defined as the internal friction or resistance produced by one layer of liquid flowing over an adjacent layer with different velocities. 9. Small raindrops are spherical in shape. Why? The free surface of the liquid has a tendency to have minimum surface area due to surface tension. For a given mass and volume of a substance, the sphere shape has a minimum surface area. Hence, liquids having high surface tension have a contracting tendency so as to attain the minimum surface area and tend to form spherical drops. Therefore, falling liquid drops are spherical. 10. How modern periodic law differs from Mendeleev's periodic law. Mendeleev's periodic law is based on atomic weight of an element i.e. elements are arranged on their increasing atomic weight, but modern periodic law is based on atomic number of an element i.e. elements are arranged in S, P, D and F subshells on their increasing atomic number. 11. Define electrophile and nucleophile with example. Electrophile are positively charged species or neutral species having an electron-deficient center which attack at electron-rich center. Lewis acid is an electrophile. E.g. Na+, H+, R+, AlCl3, Bf3, etc. Nucleophile are negatively charged species or neutral species having electron-rich center which attack at electron-deficient center. Lewis base is a nucleophile. E.g. O, Cn, Cl, NH3, H2O, ROR, etc. 12. What are deliquescent, hygroscopic and efflorescent solids? Write examples. Deliquescent solid is a solid substance that absorbs moisture from the air and becomes liquid. E.g. NaO, Cackle2, Co, etc. Hygroscopic solid is a solid substance that absorbs moisture to form hydrated substance on exposure to air. E.g. salts like Na2CO3, 10H2O, NaSO4, 10H2O. Efflorescent solid is a solid substance which is formed when hydrated solid substance loses one or more water molecules from water of crystallization at ordinary temperature when exposed to air. E.g. FeSO4, NaSO4, H2O. 13. What are proteins and carbohydrates? List the functions. The complex nitrogenous organic compounds which are essential for the growth and maintenance of life are called proteins. And carbohydrates are the polyhydroxyaldehydes, polyhydroxyketones, are large polymeric molecules which on hydrolysis produce polyhydroxyaldehydes or ketones. Functions of protein and carbohydrates. Proteins are building blocks of the various tissues. Proteins perform many biological functions. It acts as the major source of energy for animals and human beings. It stores chemical energy in plants in the form of sugar and starch. 14. How do you separate aldehyde from ketone? Aldehyde and ketone are similar carboxylic group, but they can be separated by Tollin's reagent test. In Tollin's reagent test, aldehyde forms carboxylic acid and silver mirror but ketone does not. So, we can easily separate aldehyde from ketone by Tollin's reagent test. 15. How do you differentiate ethene from ethyne? Ethene and ethyne can be differentiated by polymerization reaction. In polymerization reaction test, ethane polymerizes to form polyethene but ethyne polymerizes to form benzene. So, we can easily differentiate ethane from ethyne. 16. Write any two types of chemical reactions with example. Decomposition reaction. A reaction in which a single compound breaks into two or more than two simpler compounds is known as a decomposition reaction. Example. CaCO3 right pointing arrow SO plus CO2. Displacement reaction. A chemical reaction in which a more reactive element displaces a less reactive element from its aqueous salt solution. It is also called a substitution reaction. Example of displacement reaction. Zn plus CuSO4 right pointing arrow ZnSO4 plus Cu. 17. State Boyle's law. Boyle's law states, at constant temperature, the volume occupied by a given mass of gas is inversely proportional to its pressure. Let P be the pressure and V be the volume of a given mass of gaseous substance then at constant temperature. V1P. Or, V equals Kp. PV equals K. 1 here, K is proportionality constant. 18. State Charlie's law. Charlie's law states, the volume occupied by certain mass of gas increases or decreases by 1/273 parts of its volume at 0 on every 1 rise or fall in temperature at constant pressure. Let V0 be the volume of certain mass of gas at 0. Now, volume of certain mass of gas at -1 equals V0 1/273 of a volt O. Volume of certain mass of gas at -2 equals V0 2/273 of a volt O. Volume of certain mass of gas at -273 equals V0 273 273 of a volt O equals 0. Volume of certain mass of gas at -274 equals V0 274 273 of a volt O equals V. 19. Dalton's law of partial pressure. Dalton's law of partial pressure states, the pressure of a mixture of self-non-reacting gases is equal to the sum of partial pressure of constitution gases under the similar conditions of temperature and volume. Let us take an example of 3 self-non-reacting gases A, B, and C. P1, P2, and P3 be the partial pressure of these gases and Pt be the total pressure of gases mixture. According to Dalton's law of partial pressure, Pt equals P1 plus P2 plus P3. In general, Pt equals P1 plus P2 plus P3 plus Pn. 20. State Graham's law of diffusion. Graham's law of diffusion states, under similar conditions of temperature and pressure, the rate of diffusion of gas is inversely proportional to the square root of the vapor density of the gas. Let R be the rate of diffusion of gas and D be the vapor density of gas. Mathematically, R alpha 1 square root D. 21. SO2 diffuses slower than O2, why? The rate of diffusion of gas is inversely proportional to the molecular mass of the given gas. Here, the molecular mass of SO2I, E64 atomic mass units is higher than O2I, E32 atomic mass units. As a result, O2 diffuse faster than SO2 due to inverse relation between rate of diffusion and molecular mass of a gas. Hence, SO2 diffuses slower than O2. 22. Write importance of solubility curve. The importance of solubility curve are: the solubility curve helps us to predict which substance will crystallize out first from a solution containing 2 or more solutes. The solubility curve helps us to compare the solubilities of different substances at the same temperature. 23. Differentiate between crystalline and amorphous solid. The differentiate between crystalline and amorphous solid are S, N. Crystalline solids. Amorphous solids. 1. Constituent particles are arranged in an ordered manner. Constituent particles are arranged randomly. 2. Definite characteristic geometrical shape. They have a regular shape. 3. They have a definite heat of fusion. They do not have definite heat of fusion. 4. These are true solids. These are pseudo-solids or supercooled liquids as they possess characteristics similar to liquids. 5. Examples: sodium chloride, quartz, etc. Examples: glass, rubber, plastics, etc. 24. Define isotropy and anisotropy. The properties of a material are identical with different directions, i.e., they are independent of direction. The structure of the minerals is uniform, amorphous. This type of behavior is called isotropy. Isotropic minerals have same and consistent chemical bonding. The properties of a material vary with different directions, i.e., they are dependent on direction. The structure of the minerals is not uniform crystalline. This type of behavior is called anisotropy. Anisotropic minerals have different and inconsistent chemical bonding. 25. Define Aufbau principle. Aufbau principle states, while filling electrons in atomic orbitals, electrons are first filled up to the orbital having lower energy, then only filled up to the orbital having higher energy. The relative energies of the subshells or orbitals, as determined by spectroscopic studies, is 1s less than 2s less than 2p less than 3s less than 3p less than 4s less than 3d. 26.